To my colleague Steve Diamante, and I'm calling him Steve Diamante rather than Steve Bio, which is here in front of me. Well, Steve's a really clever guy. He's got a PhD, and although those of you who have got PhDs will know that in the academic community that means permanent head damage. But in fact, in Steve's case, it doesn't seem to have affected him at all. So Steve is really very much a professional, serious chemist. He has a very interesting background that you can talk to him about in other areas outside optics. But as well as being a chemist, he also has a master's in science and engineering from the University of California, and he's got a bachelor's as well from Carnegie. We were talking about the pronunciation of Carnegie, a great Scottish name, Carnegie Mellon University. Steve's been a really critical part of our research efforts over recent years, and material chemistry is his thing. For those of you who love MyDay, and obviously a few of you do, you've got him to thank for a lot of that development. He understands silicon hydrogel technology, I think, probably as well as anyone walking around on the planet today. He's been with the company for nearly 5 years, and is one of those rare researchers who's gone sort of really beyond his research brief, and in my time with the company, I've certainly seen Steve add a tremendous amount of knowledge to marketing and sales groups, and indeed customer groups as well. So it's my very great pleasure to introduce Steve Diamante.
Thank you, Joe, for that kind introduction. So let's get started. So I'm going to talk to you today about the development and material chemistry story of MyDay, the material. And originally, I had this title as "Let's Make Contact Lenses Great Again." But Joe informed me that phrase doesn't work as well in the rest of the world as it does in the United States. So I changed it to something much more serious and much more professional. So I'm really going to focus on the science behind the technological breakthrough that is MyDay. Those of you that have been in the optometry field for some time know that when we brought out the bioaffinity material, it really broke the mold of what a silicone hydrogel lens could be. And with the MyDay material, we broke that mold yet again in what a silicone hydrogel one-day material could be. And so I'm going to talk about how we achieved that. But first, let's start with innovation. Right, coming from R&D, that's our bread and butter. That's what we do. And you can define innovation in a lot of different ways. One way that's the most apparent to you as optometrists is new product launches. And in the last 10 years, CooperVision has been leading the contact lens industry with launches of new and differentiated contact lens materials in the monthly segment, the biweekly segment, as well as the one-day segment. And even with that, we don't rest on our laurels. So we know we had a very popular and successful contact lens material in Avera, and we knew we could do better. So we actually upgraded our own 2-weekly lens with all the knowledge we've gained over the past 7-8 years in silicone hydrogel chemistry, and came out with the new Care contact lens. We strongly believe at CooperVision, our development philosophy is that there is a best contact lens that we can come up with for each unique wearing modality. So we think a 1-month material requires different properties than a 1-day material. And so we try to optimize each contact lens material for that unique wearing modality. We're not unique in that, but certainly there's some other companies that don't share that same product development philosophy. So we talked about product launches, which is what you guys see. But really, this is just the tip of the iceberg when you're talking about research and development. Because behind every product launch, there's a mountain of research programs. So looking to understand fundamentals of how silicone materials interact with the eye and what determines good wettability on the eye, as well as fundamental research that we do on developing new building blocks for contact lens materials. And so behind every product you see, there's blood, sweat, and tears of many different chemists and clinical scientists that have gone into making that product. And so I want to talk a little bit about what's enabled us to achieve this market-leading space of being the innovators in silicone hydrogel materials. And we're lucky enough that we have some great core technologies. And so I'm going to talk about chemistry first because it's my love. Chemists are very clever people. They have a dear place in my heart. And so you're probably aware of some of these fundamental technologies that are part of our blockbuster contact lenses. So we started out with the PC hydrogels. Then it became apparent the value of silicone hydrogel materials for ocular health. And so we developed unique materials utilizing aquaform technology in the case of bioaffinity and smart silicone chemistry in the case of MyDay that really enabled us to make lenses that solve some of the compromises of other silicone hydrogel materials. And so to do that, we had to utilize our core skills. And one unique core skill of CooperVision is that we not only know how to blend together different chemicals to make a great contact lens material, but we actually know how to make unique silicone molecules from scratch in our labs. So in the case of bioaffinity and in the case of MyDay, we actually made totally new molecules because that's what enabled us to break the mold of what silicone hydrogel materials could be by starting from scratch. And of course, we have great formulation experts. And over the years, we've developed a strong understanding between the chemical structures we put into contact lenses and the properties that we get out of the finished product. Of course, we're also known as experts in lens design. So our aspheric optics are well known. Joe talked a lot about optimized toric lens geometry. And we've even had some new innovations in this space, such as digital zone optics and our MySight contact lens. And that really comes from the people, having expert lens designers, excellent process innovation, so these materials don't stay in R&D. We can actually scale them up and manufacture them, and certainly not least clinical scientists. So we attract and poach the greatest minds in contact lens research, and we're shameless. We'll steal great talent from anywhere across the world. So you might recognize some faces from the Brian Holden Vision Institute. So we really look across the world for the best clinical scientists, chemists, and lens designers we can find. Because it's really our investment in our people, in research and development, that enables us to make the best contact lens materials we can. And some of you might recognize that face as well. Okay, so these people at R&D sound like really clever, they sound really clever. So what can't they do, right? They can make contact lens materials, they can make these excellent innovative lens designs that are unique to the market. They're continuing to come out with all these new products. So what we can't do is we can't fit lenses on eyes. So that's where we depend on our partnership with you as optometrists, because from R&D we can produce great contact lenses. But without optometrists fitting them on patients, they'll stay on the shelf. And so it won't be possible for patients to enjoy all this new and innovative technology. And I think Joe made a great point that it shouldn't just be new wearers that are coming in that are getting the latest and greatest technology. There's a lot of opportunity to upgrade existing contact lens wearers. Okay, so another way to talk about innovation. We could talk about the single most important development in the contact lens industry in the last 30 years. And some of you might have a lot of different opinions on this. And Contact Lens Spectrum actually published an article on this in last year, September. And they interviewed a lot of prominent contact lens researchers, as well as contact lens practitioners. And interestingly, there were the top two answers, which won't be surprising to this audience based on your fitting behaviors, were the development of a frequent replacement product, particularly one-day disposable lenses, and silicone hydrogel materials. And so Joe talked a lot about hypoxia and risk of hypoxia, and some of that leading research, of course, was done at the University of New South Wales. And I think Professor Nathan Efron captures it best when he says the introduction of these silicone hydrogel materials has not only been a great benefit to patients, help avoid the complications of hypoxia, but also a great benefit to practitioners with having to spend less of your time to solve these former contact lens complications that we're seeing in the past. So, okay, so great. So one-day disposables are one of the most innovative things in the last 30 years, and silicone hydrogel is as well. And what a great thing that we can put both of those together. Right, but there's been some debate recently about what oxygen transmissibility criteria we should use, because there's a few different numbers out there. And so with that question, I really like to look back at the work of Eric Pappas, who said that it does not seem unreasonable for a clinician to attempt to satisfy the highest oxygen criterion that available lens technology will permit. Okay, so the highest oxygen criteria. And so you're all quite smart, and Joe's informed me that you know that the DK over T that you see on your sales aid and in your blister packs is taken in the center of a -3 diopter contact lens. And of course, that's the thinnest part of the lens. There's nothing we can do about that. That's the international standard that was determined. But that really is a best case scenario. So at CooperVision, we didn't want to stop there. We wanted to see what was the real story. So what's the real oxygen transmission? And so Joe got the pleasure of showing those pretty oxygen maps first. But this is actually how we got those images. So we partnered with a company called Face Focus. It's based in the UK. And they actually have instrumentation that allows us to measure the thickness of a contact lens at every 7 microns. Okay, and to put that in context, the thickness of an average human hair is 50 microns. So across the thickness of one of your hairs, they'd be taking 7 measurements. So that's the level of detail at which we're able to determine thickness of a contact lens. Now, of course, we know the DK, or oxygen permeability, of all contact lens materials, because that's a published value. So taking this thickness map and the DK of the material, we can then create an oxygen map across the entire contact lens surface. And so when you do that, then you get the whole picture. And it becomes really clear of the imperative we have to not only fit new contact lens wearers in the healthiest material, which you're already doing quite well, but to move over some of these poor hydrogel wearers that are languishing, these existing wearers that are languishing in hydrogel materials. Now of course Joe talked about it. This is very dramatic in toric contact lens designs, because you have to have these thick stabilization features which can make the lens very thick. But actually, even in spherical contact lenses, hydrogel materials cannot satisfy even this lowest DK over T requirement across the lens of any single power and across the power range. And with silicone hydrogel, because you're starting with inherently higher oxygen transmissibility, you can do that. And so, of course, you guys already know this. That's why you prescribe silicone hydrogel. That's why we have that great data that Joe showed from Australia. But this could be a really nice tool to use with patients to explain, look, this is why I want to put you into a new contact lens material. And here's a very visual look at the benefits. Okay, so let's get to technology. So when we started to develop MyDay, it was very clear there was a gap in the one-day contact lens market. The one-day contact lens market was full of hydrogels, and there was only one silicone hydrogel. And so we went out and asked consumers, what is it that you want in a contact lens? Because if we were going to make a one-day material, we wanted to satisfy all wearers' needs, not just satisfy some of them. And so some of these things are really obvious, right? You hear these all the time. I want a contact lens that's comfortable at the end of the day. I want great value. I want my contact lens to be healthy. One thing that was a bit surprising to us and hadn't had a lot of focus is that it's very important for contact lens wearers that the lens is easy to handle. And in fact, we did some more digging on this, and we found that the #1 reason for contact lens dropout in the first 6 months is not poor comfort. It's actually difficulties with handling. So having a lens that's not only comfortable at the end of the day and healthy on the eye, but is easy to handle and easy to train new contact lens wearers is really critical for new contact lens wearing patients. And so, as a chemist, I had to look to what material properties I wanted to design the lens around. And so the first thing that we looked at was making an extremely soft silicone hydrogel material. And we thought this was important, and I'll get to it a little bit later in more detail, but it was basically because you had this situation where you had very soft hydrogel materials and much higher modulus or stiffer silicone hydrogel materials. And so we wanted to change that. We wanted to make a soft silicone hydrogel. Of course, water content is important, and CooperVision is known for our naturally wettable technology, right? Designing in wettability from the beginning, from the molecular building blocks. So we have an optimal water content and natural wettability, so we don't need coatings. And then finally, high oxygen transmissibility. And so, since I'm a scientist, I love to show graphs, right? We all like graphs. And so this is pretty simple. So, in the y-axis, you see modulus, okay? And modulus is a fancy scientific way of saying how stiff or soft the contact lens is. So as this number gets higher, you're getting to a stiffer material.